Again, no calculators provided, a cubic function. We're given a cubic function, so we know these specific points. So if you did not know this, my input is -3, my output is 2. My input is -1, my output is -3. Input is 4, output is -3. Please make sure you have those down, and I want to verify that I wrote them down correctly. That is correct. Before I get started, that is correct, and that is correct. Additionally, f of x only has 2 distinct zeros that exist on this particular interval. So let's circle 2 distinct. You may want to write the words 2 unique. I'm going to flip it over to the other side just to remind ourselves about multiplicities really quick. How many distinct in this particular graph? How many distinct zeros do we have? 1, but what is a multiplicity? 1. How many distinct zeros do we have here? 1, what's the multiplicity? 2. How many distinct? 1, what's the multiplicity? 3. Awesome, let's flip back over here again. I want you to graph these 3. We're going to graph a possible sketch. So all of our sketches could be like slightly different. But before I get started, what type of function is this? Cubic. So if it's cubic, I want you to think about the end behavior. Within your groups, you have 20 seconds. What would be the possible end behaviors? We have 2 options. Go. What are the possible end behaviors? Up to the right, down to the left, or down to the right and up to the left. Cubic means the degree is 3. Whenever we have an odd degree, it's either up on the left, down on the right, or vice versa. Okay, it depends on that leading coefficient. So I know it's going up here and down here, or vice versa. So I'm going to start by graphing these points. So -3 and +2, -1 and -3, and +4 and -3. Now, how many distinct zeros are there? Oop, that was a -3, wasn't it? Good thing I didn't start. 1, 2, 3. All right. How many distinct zeros? This is important. There are 2 distinct zeros. I want you to give yourself time as a group to see in 2 minutes if you can come up with what you think this could look like. This is a sketch, a possible sketch, and then I'm going to come up with one. And if you are watching this video back because you're in periods 1, 2, or 4, do the same. Press pause. So here we go. You ready? So between -3 and between +4, so in this range right here, there's 2 distinct zeros, just 2. So I know I need to get from here to here. Do you guys agree? So I'm going to connect those. And I believe this is probably going to go then up in that direction. Okay? And then now I need to get from here to here. But how many more zeros can I have? I can only have 1. So how do I get from here to here but only have 1 zero? If, and I've seen this on papers when I've just glanced at, I've seen some kids, this is not right, have gone up and then back down. Well, how many zeros would I have now? If I did this, I would have a total of 3. So how can I still have it? I could come up, and it doesn't matter where it hits, but in between here, it could come up and it's going to bounce off and then go back down. Does the end behavior of my possible sketch, does it resemble a cubic function? Why? Why does my end behavior resemble? Because cubic functions have a degree that's odd, and odd end behavior goes in opposite directions. Okay, are you ready? Let's do the domain and range. So I'm going to put down the domain of, and there's different ways we could write this, remember, the domain and the range. So the domain here is -infinity to positive, and the range is -infinity to positive. There's no limit how far it goes to the left. There's no limit how far it goes to the right as well. State the multiplicities of the 2 distinct zeros. So I'm going to say one of my zeros potentially is at -2.5. X equals -2.5. And what is that? My justification is that this is a multiplicity of 1. This is a multiplicity of 1. Now, I need to justify that. That means you need to not only share what the multiplicity is, you need to share how do you know that. And the reason why I know it has to only have a multiplicity of 1 at this point is because I need to be able to connect the points. So I need to be able to connect -3, 2 to -1, 3. And the only way to connect those is to go straight through the x-axis. That's my justification. Simply saying that it has a multiplicity of 1 will not get you the points you need. So please do that right now on your paper. Whatever your graph looks like, what is your 0 at this point? The multiplicity is 1, and then how do you know that? You need to put that in words. How do you know it has a multiplicity of 1? And I'll state it again. To get from this point, -3, 2, to -1, -3, to connect those, I have to cut straight through the x-axis. Cutting straight through the x-axis, diagonally, is an example of multiplicity of 1. Okay? The next one, for me, it is at +2. So my other distinct 0 occurs at +2. This has a multiplicity of 2. And how do I know that? Because it bounces off the x-axis. It goes from the point -1, -3 back to 4, -3 by bouncing off the x-axis at +2. So I want to really, really drill this in. You're going to state what the 0 is, what the multiplicity is, and then how do you know that's the multiplicity? This is what I see happening on the graph. Really, part D is just backing up part C. So are you ready? I want you to decide right now, whoever is the tallest in your person in your group, I want them to answer part D. Hold on. I want everybody else to be the judges, and if you were grading this, listen closely, you happen to be an AP grader. Listen to their answers. They don't have to put it on paper. Listen to their answers, and I want you to decide, do you think they fully answered that question? You have 30 seconds to get this done. Go. Explain why the function f of x is guaranteed to have a 0 of odd multiplicity. By the way, multiplicity of 1 is odd multiplicity. Multiplicity of 2 is even. Multiplicity of 3 is odd. Okay? Just so you understand. Ready, get set, and go. 30 more seconds. And so if you are watching this is -3, and this is -1. In order for me to connect this and to sketch this graph, to go from the points -3, 2 down to -1, 3, I have to connect or cut straight through between the range of -3 to -1 on the x-axis. Cutting straight through is an example of a multiplicity of 1, and multiplicities of 1 are odd multiplicities.